Question 4 I thought was reasonably nice. It's quite short anyway, so we'll have a little look. We are proving this, basically. You could also be proving this one, or you could also be proving this one. So you could have cos or sine or tan. Whenever you're asked to prove any of these, you're going to use these ones above. Okay, but instead of a plus b, you'll have a plus a, because a plus a is 2a. This basically means, look, if you've got cos 40 plus 30, you can work out what cos 70 is by just putting 40, 30, 40, 30 and doing the math. But what if it was 30 and 30? What if these are the same, basically? That's what the 2a is all about. So if you're doing this one, you've got to use this one. So that's what we've done. So 2a is a plus a. Cos a plus a, I've just used the formula I was just pointing at. So it's cos a, sine a, sine a. Notice, and again, I don't want to hammer this home too much, but basically that's just an a now, and that's just an a now. That's all I've copied. The b's into a's. Right, cos a multiplied by cos a, anything times itself, that's what squared means. And sine a times sine a, anything times itself, that's what squared means. And look, we've done it, it's 2 lines. Okay, next one. Right, they give you a value for sine. Now, if you wanted to, you shouldn't, but if you want to, you could do inverse sine on your calculator to work out what theta over 2 is, and then you could just do cos of that answer, and you'd get what cos is. It just wouldn't give you the exact thing that they want, but you'd be able to go through and do the question from there. Right, one thing to notice, this is part 2. It's not part B. You haven't moved on. So it's almost like them saying, look, you have to use this thing above. So we are going to do that. So first thing, they give you this sine thing. Now sine, if you look it up in the trigonometry section, sine is this A and this C. So I've just put the 1 and the square root of 5 onto this triangle, and I'll put the angle on. And from that, with Pythagoras, you can work out this 2. So square that, subtract them, square root, you get this 2. Then cos, because they're talking to me about cos. Yeah, cos there. So we're going to need some coses. So cos then is going to be 2 over root 5. So cos of this angle is 2 over root 5. And again, this is just basic trigonometry. It's just this triangle, okay, that we're doing. So cos is b over c. Right, so this is what we've got. Now, we have to use the thing above, and we have been asked to work out cos theta. Now, cos theta, using the thing above, and this is the only reason why I've even thought to do this, is because, okay, it's part 2. What if I had half of theta plus half of theta? That's a whole theta, isn't it? So I've basically split this in half. Now, why would I do that? It's because they've basically told me I've got to use this. So this 2a is 2 of those. Okay? So then, you've got cos squared theta over 2 minus sine squared theta over 2. That's just from this. Okay? Fine. So now, we know what cos theta over 2 is, because we just worked it out. It's 2 root 5, 2 over root 5. So you put that in. They've given us the sine one, is 1 over root 5. The squares are still there. We have to square this bracket, which gives you 4/5. We have to square this bracket, which gives you 1/5, and then you subtract them, which gives you 3/5. Right. We've got to solve an equation. It's a trigonometry equation, and it's in a range. So you're going to get 2 answers or 3 answers or 4 answers. It's this cast thing. Or it's using the graph. So there's 2 valid ways of doing it. Okay. So first thing we do, you're going to move this tan over here, tan minus 1, and you'll get minus 60 degrees. This is in degrees, so we can work in degrees. So minus 60. Draw your cast. Minus 60 is down here. We normally work this way. We normally work anti-clockwise, but because it's minus 60, we're going to go clockwise there. Now going anti-clockwise, this means that this is 300. Now the minus this thing up here, the minus root 3 means, and the tan, means that we can't be in the tan and we can't be in the all, because we've got a negative. Okay, so we need to be not in the cos and we need to be in the sine. Okay, I've drawn all 4 lines. Now all 4 of them have a 60 degrees between the line and the x-axis. So there's a 60 here and there's a 60 here. Okay, but we're only interested in the sine and the cos because we want negative tan. Okay, so everything's positive here, so we don't want that. Tan's positive here, we don't want that. You're here and you're here. Right, so going around this is 180 but minus 60 because we're going anti-clockwise. So it's go around to 180 but take the 60 off, 120. This one is go all the way around to 360 but take the 60 off, it's 300. Those are your 2 values, 120, 300, put those there. Then, we know now that the bracket at the beginning, this bracket here, equals those 2 numbers. So this is going to equal 120, or it can equal 300. Now we know that the 120 can change by 360s. You can add 360 on lots of times, you can take 360 off lots of times. Now, what do we do with this 150? We're going to subtract it. It gives us minus 30. Now, minus 30 is our answer, it's great, but it's not in our range. Okay, so how can we get minus 30 to be in this range? We add one lot of 360 on, so 330 is the answer. If you come to the other one, we had 300, if you remember, there was 2 answers, 120, 300. We used the 120, gives us an answer of 330. The 300, you just subtract the 150 off. Oh, it makes 150. That is in our range. You don't need to do anything with this. If it's outside the range, add some 360s or take some 360s to get it into your range. So 150 is the answer, 330 is the answer.